Hi guys, welcome to my blog. Today we're going to review the latest post called GraphQL Gateway Architectures. So I've been playing around with different approaches on like adding a gateway, GraphQL gateway in front of different services, like in microservices architecture. I found these four approaches using remote schema stitching, using schema stitching through shared interfaces, a hybrid remote schema stitching approach, and using Prisma's GraphQL bindings. So we'll go one by one explaining these approaches, and hopefully you can get something out of it. Let's go into the first one, remote schema stitching. This is the most straightforward one, or nothing really inventive here. In my case, I'm using Apollo Server 2 to do the remote schema stitching. This is stitching to one, two, or more GraphQL APIs, and you have remote GraphQL APIs. For these, here you can see how it is done in Apollo server. You might want to take a look at the server that you are using as a gateway, how this is done. The only things that you need to have in mind when you go with this approach is you might have to resolve any conflicts if you find them when you introspect different remote APIs. So you might need to choose, in the case that you have conflicting types, you will need to choose one. You also, there's in the case of Apollo server, I'm not sure in other servers, you can transform types or filter types or rename them. You have some actions that Apollo lets you do. So in case that you have, again, it might be conflicts, or you might want to make type names more clear, things like that, you can add transformations to them, to the stitching itself. But this is that you need to have in each service like the GraphQL server with the resolvers in there, and the gateway becomes like a DAM service. So yeah, that's the first approach. Okay, so let's go to the second one, schema stitching through shared interfaces approach. So this means that basically services A and B publish an npm package with the schemas, and they are not GraphQL servers themselves. They are just plain services exposing the interface that they want. In this case, as an example, I'm giving that A exposes gRPC as a service, and B just listens for Kafka events. But they expose a GraphQL interface with an npm package or whatever method you find best, and the gateway itself installs those schemas, and it builds the API locally. This means that the gateway needs to resolve all the types and all the other resolvers, mutations, subscriptions, everything in the gateway. Good thing about this is that you have the source of truth of the API. The final API is there. You define it with these static files, and you don't depend on remote APIs that might change and might break the gateways in some way. But at the same time, everything stays in the gateway. Like all the resolvers and everything is in the gateway. So a lot of teams and people will start making changes there. The cohesion is pretty high. You'll find yourself changing a lot of times. Service B and the gateway, service A and the gateway, and so on. So this might be some a good approach for pretty small gateway, with a very few services, or maybe with something that is owned by the same team. But it's one way of doing it. Okay, now let's go to the third one, the hybrid remote schema stitching. This is a very small variation from the previous one. This is using schema stitching for one service, but then resolving the query using doing the resolver in the gateway for another services. In this case, B, other requests to B are resolved through stitching. So for example, B has a person type, and if the client requests for a person, then the gateway just delegates the query to B through stitching. If not, if I don't know, A resolves orders, let's say, so the gateway will have the resolver that does the gRPC request to A, gets the information and passes back to the client. This is one other way of developing the gateway. Finally, the last approach, using Prisma's GraphQL bindings. This uses the technique of generating an SDK for your GraphQL API. So instead of the client interacting directly to with the GraphQL API through queries, those queries usually they are validated against the schema introspection or the schema if the client has it there, while developing. I'm saying. So the client has to know how to do those queries, and it's sometimes easier to expose or distribute an SDK, or in this case a GraphQL binding that the client can use to interact with the GraphQL API to easily, say, API dot create person or whatever. And in that case, the client doesn't have to know how the query is built, or they can have types to know what things can be passed to create a person, and let I don't know, if you're using TypeScript, you can let TypeScript check if the things that you're passing are the right ones and things like that. So the collaboration diagram would be something like, in service A has a distributes binding, GraphQL binding for in GraphQL API, and then B does the same. A and B, are GraphQL servers themselves, and the gateway have the resolvers for them, for all the types and everything, types, resolver, subscription, and everything. And what it does is it calls the bindings of the different services. So in the case of resolving A's orders, then it will say, A dot get order with this ID, this something else, and then the binding itself will know what query to use and get the information, and that information will go back to the client. So it's similar to the shared interfaces approach, but in this case, instead of knowing exactly how to resolve the query, you let the binding do it, and that binding can use any technology. It can use gRPC, REST, Kafka, whatever method it wants to communicate with the right service. It can communicate to more than one service if necessary. So in a way, the gateway is dumb in the sense that it uses the bindings, but it doesn't know how the bindings work. And the bindings are developed probably by the team that develops the A service in the case of the A binding. So you decouple that, and in the case that a change has to be done to A resolver or B resolver, you actually are changing the binding. You don't need to touch the gateway. So if a developer from the service B has to change something there, it changes B and or B's binding. The gateway doesn't become like a bottleneck of modifications. So the conclusion, as always, on which approach to pick, it really depends on your team or your team knowledge, the time that you have, the technology that you're using, the stack, and so on. Depending on these factors, you might choose any of these approaches, or you might even have another one with different concepts that I haven't covered here, and that's totally great. If you find the video useful or the post useful, please give the video a thumbs up, subscribe if you'd like. I'll continue working on these videos and on different posts, and also comment on the video or the post, share them if you find it useful. Thank you. To the next one. Cheers.